Hello guys, we're going to do a video today on kind of answering some questions again, but this is a promised video I said that I would be doing on multi-position switches like rotary switches or even just switches in general. I thought, well, I had a few other comments and questions, so it seems to be that switches sometimes are a little difficult to understand, so I'm going to make this kind of short as much as I can. So some of it I'll go through kind of fast, but I got a small assortment of switches here. I got some more over on the side. So I thought I would show you basically different types of switches. So one switch, switches that you may find, especially on like TRF radios and radios from the 20s, early 30s, is toggle switches. You just basically it's on, off, which it tells you right here. They come in a variety of different styles. Most of the ones that you would find may appear more like this construction as opposed to this style. This is a little newer. Well, this is actually a newer switch. But a lot of the old switches were layers of insulating material with metal, different contact metals in there, and then of course the toggle would flip a contact in there back and forth. But some of your standard switch that you probably find is one like this, where one direction it's on, the other direction it's off, and this is called a single pole, single throw switch, primarily because you only got one connection, one line that you're powering up or making a connection in. So it's your single pole. So it basically two wires hooked. You get one wire that'll be like, say, feeding power in from your cord, and the other wire going out to the radio, either the power supply, the radio, and you flip it one direction, it's on. Flip it the other way, it's off. So it's just a single throw, which means it has an on and off, and a single pole, which means there's just one line that this breaks and closes. Another style switch would be the single throw double pole. Again, single throw because it only clicks on in just once. One on. There's not two ons, so it only throws one way to close the switch. But it's double pole because now you're breaking two lines. Some manufacturers would use these as power switches. What they would do is on the cord, both wires in the cord, so the hot and neutral would be connected, one here and one here, and then it would feed out. One side will go to one side of the transformer, and the other side transformer if it had a transformer in it. The reason they did that is when it's off, it literally completely disconnects any of the power to the radio. Neutral and hot is completely disconnected. So anyway, you got two wires that you're going to put the switch into that you're going to break. Single throw because it's only got one on. Another style is like this. This is a double throw, double pole. Double throw because it has two different on positions. It's on that way, it's on this way. In this case, it's double pole. You're still breaking two basic wires. One wire hooks here, one wire hooks here. This is just common. When it's flipped one direction, it'll hook to, say, like this position here, and this wire. These two are connected, these two are connected. When you flip it this way, these two and these two are connected. So it's double throw. And some others that you might run into, some radios had it so that they put a switch connecting up a tap on the primary and then another point on the primary. They'd run neutral or one side of the line cord to the other side of the primary, and then this switch would be in there, and then you'd have the power switch before it. And what the switch that's hooked to a couple spots on the primary, one end of it and then a tap, is for two different voltages. Say, you know, like a range of 100 to 105 volts in one position that you could plug into, and then the other position may be 115 to 120 or something of that nature. And it would be a switch that looks like this, where you've got three connections to it. In one position, these two are connected. In the other position, these two are connected. Now this is a single pole, what they would classify as a single pole, but double throw. In both positions of the switches, it's on. But what it's doing is, what they do is, this is the common. This would hook to the power coming from the power switch, the main switch. And then this lead might go to, say, the tap on the primary, and then this lead go to the one end nearest the tap of the primary. So when you're in this position, your power will go through here, and you would get the full primary winding connected in the circuit. And that would be like for the 115 to 120 volt range, or 115 to 125. This direction, power would then go through to the tap, which reduces how much primary winding we're making use of, and that would be for the lower voltage, like the 100 to 105 or 100 to 110, whatever they decided. An interesting thing to point out about this switch, single pole double throw switch, if you're doing with house wiring, say you got a hallway and you want to have a switch at each end of the hallway to operate the hallway light, well, you'd go out and buy a couple what they call three-way switches and wire it all up. And that way, at one end of the hallway, you can turn the light on, go through the hallway, and when you get to the other end, you can flip that switch, and that would turn it off. Coming back the other way, you flip that switch, turns it back on, go down and flip the other switch, and it'll turn it back off. They're exactly the same thing as this switch. Single pole, double throw switch, except you won't have solder joints, you'll have screws that you hook your wires to. And the common wire, or the main wire, the wire switching to either one of the other two contacts, will be usually a dark color or brass color, and then the other two would be more of a silver color, so you knew which one is common and which one is the two switch legs. Just thought I'd point that out. And there's various other types. You've got, here we got a double throw single pole, again, just one power in, and power in, power out, power in, power out. But this one, unlike this one, which it has only two positions, this has a center off, and you can see it says on, off, on. So when you flip it this way, a couple of these are connected and it's on. Here it's completely off. Here it's on again, and then the other two would be connected. And then some other styles that's in this kind of would be like a push button switch. Now some of these, when you push it, it's on. Push again, it's off. Some of these are momentary. In other words, as long as you hold it down, it's on, but you let off of it, it's closed, or it's off. And that's what this type of switch is here. Another style push button that you may find in like tube testers is one built like this. It's got these little contacts down in here, and right now the two top ones here, the very top is just a spring, but the second one down and the third one down are in contact, but when I push it down, those two break, and then the bottom one and the third one down makes contact. But you may you'll find these in a lot of tube testers, and you know, they use them for, like, well, they can even use them for doing your checking the tube. You just push down and then applies the power to the tube, and then you check it for how good for the quality. Another could be for gas test, leakage test, things of this nature. Some other switches that you'll run into is slide switches, where you've got a, you know, it just moves back and forth. This one, some of these will stay on. You push in and it locks, and you push it again and it unlocks. Others are momentary. This one's momentary. It don't lock on. And it's basically they cut off one of the things here for wherever it was in, and just making use of these two. When it's pushed in, those two are connected. If this one was still here when it was out, then these two would be connected. But just a simple slide switch. I took a couple of these apart just to kind of show you the looks of them. You got contacts here and contacts here, and the contacts on the slide, which moves back and forth. This is a locking type. It locks and it unlocks, and these will slide against these contacts here to either hook up these two or hook up these two. Same way here, these two or these two, these two or these two, depending on which position the switch is in. Another way of doing it is a switch. This is your slide. You got a couple round little contacts, and this is the part that it runs against. When it's in this position here, these two up here are contacted, these two are, and when it moves, it would then move to these two and these two. And then there are lever switches. I got 3 different ones here. Some of these lock in position. They basically got a phenolic. It's very similar to a rotary switch, and just making different contacts here. In this position here, we'll just look at these right up here, but you can kind of get a visual from the rest of them. But right now these two are contacted. You flip it this way, now these two are contacted. The center one's always staying in contact due to the metal slide, so it always stays in contact. That makes it the common, so it's either going to switch these two on or these two here on. Same way down here. So, and these can be double-sided. You can't really see it inside there, but it's identical. This side is literally identical to this. So in essence, with this switch here, we have actually 4 switches in one. We got a switch action here, a switch action here, a switch action here, and a switch action down here. Another style is like this. These are kind of hard to see, and I don't know if I can get focus in there. There's some contacts down in there and stuff. This is a momentary. I push it, and if I let it loose, it'll just come back on its own, so it don't lock in. On these, when you see these style, whether they're in a lever switch or a rotary switch, the conductors in the center, the wire ties that's in the center here, are your commons. They're where you apply whatever you're wanting to switch, power, signal, whatever. In the case of this switch here, this common goes with these two contacts, this one with these two, this one with these two, and this one with these two. In one position, these two are contacting, same way all the way around. And when I push it the other way and it's in the other position, then it's the other two contacts. One very similar to it is this one. This locks in place and it has 3 different positions. In this case, again, these are all the common contacts, but in this case, this one in one position, first position would make this contact, next position would make this one to this contact, and the last position would be the last one, and all the way around. That brings us to basically your multi-position rotary type switch. And some of the things I want to show on this more than anything else, because when we get to the schematics, I want you to kind of see that, because I'll show it out on the schematics. But we're just going to look at one end of this. You see these 2 metal pieces that's on the rotary part. Well, these guys are short up here, but this one is long. And over here the same way, this one's long. These are your commons. They're always in contact with the center portion. But, and I don't know if you can see it, if I move it part way, you can see that that metal actually has a tab on it. That's what's making contact with these guys as it rotates. And back. Now you can see that a little better on a switch like this one, where this long one is the common. It's always connected to the center piece. This tab will make contact with these guys as it rotates. And we'll see if we can do this. Working around the camera is kind of fun. It makes it a little difficult, but we'll get there. But you can see how it makes contact around. Now these rotary switches come in many different styles. You can have just like basically a one switch or one rotary section. In this case, a porcelain one, where these are phenolic. You can have, 2. You can have like this one, 3. You can have 4, 5, whatever you need. The other thing too is these are put together with screws and spacers, so they can be made up and custom built, really, and with any distance between the wafer switches. And why is that kind of important? Well, things like say VTVMs or RF generators and stuff. On VTVMs, the range switch, which is where all the resistors are being tied in that I talked about, they're usually mounted right on the switch. Now some of them might be shorter, but some of the bigger resistors, like 7 megs and stuff, could be longer, and you want to have enough room just to set that right down in there. So you want these spread out enough that your longest resistors will easily fit in there. You know, you can always get the shorter ones in easily enough, but you want to be able to get the longest ones. The other thing is like an RF generator for the bands. A lot of RF generators, a lot of manufacturers would put the individual coils for the different bands right on the switch, the band switch. So, and you know, those coils can be fairly long, depending on, you know, the manufacturer. So, and by putting them directly on the switch, they needed, you know, basically one end and one wafer at one end and one wafer down at the other end, and have a pretty spread apart. Well, that's pretty easy to do by having a different shaft lengths that goes through, and different lengths of spacers, and of course different lengths of screws. This one here is quite interesting because these two are relatively close, and we got a metal shaft going up, and then we hit a coupler, and then they put a phenolic shaft in there. Basically what they were looking at is they didn't want any cross communication between these guys through that shaft up to this switch, or even from the frame and the chassis ground, as well as even from the knob end. So they wanted this isolated, and that's why they did that. But in order to get that in there, that's fairly large, they had to extend it out. And you know, you can take these apart. This is what one looks like. Sometimes they're on both sides, sometimes only a single side. Now, on schematics, when you're looking at these switches, a lot of times they'll just draw them out as they look. In other words, they'll draw this whole piece out showing the screw holes and the contacts. In some cases they'll number these all the way around, and so, you know, like position 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Most will be 12. There are some very large ones, they have more contacts on them. But if they're really good schematic, they will show you, you know, a drawing of the switch, showing the knob in and everything, just as it looks. So they draw this out. Now this does have some stuff going on the back side of these switches, so by showing that drawing, then they'll label the front and back of the individual wafers, switches, or individual switches, and they will also label these switches, you know, like number 1, number 2, number 3. You know, a case like this one, you know, they might say, looking at from the knob end, they call this 1, 2, and 3, and this one has stuff on the back, so they'd say that, or on the front, they'd say this is front because they might consider the knob in the front, so they say 1 front, 1 back or rear, and then 2 front, which does have a switch there, and 2 rear, and 3 front, and 3 rear. Now some schematics don't give you any of that information, so you kind of have to just kind of look at it, look at the radio or whatever it's out of, and kind of start piecing it together to understand which switch is which is front and back, and so forth. The other thing too is where there is no contacts on a particular side, they won't number them usually or label them. Just the ones that's got the connections. Now, with that being said, let's look at some schematics. And I'll go ahead and zoom in on this. And I'll zoom into the switch. Oops, sorry. Now, focus. Thank you. I find it interesting. Everybody makes videos, talk to their camera like you can listen, trying to get it to focus. Now, this particular radio is a Silvertone Sears, and someone watching my video will recognize this schematic. But here's your, it's basically the main switch that's in here is, there's two of them, but it's for the band switch. But as you can see, and this is right out of the riders, and even with it, it's very difficult to make heads or tails of the switches, and mainly the contacts. They're real difficult to see. I would assume the actual factory schematic, if you could get it, factory service information, would definitely be the best, and would show those a lot more clear. But the interesting thing I want to show you, there is zero information on this. They don't even have arrows telling you which direction the switch goes. They don't have much information. They don't number them. You don't know where the screw holes is. You don't know which is front and back, top and bottom, so on. So you kind of got to compare the switch more or less to the switch in the radio. Yeah, they don't have any. I was trying to think if there was any other information anywhere else. So this is sometimes what you can run into as the worst case scenario, where you really just don't have hardly any information. Now, some of your better schematics will show I may have to back out just a smidgen. Well, for one thing, first I want to kind of zoom in here. Let's see if I can get it to focus. Alright. I may not get it to go any better than that. You may not be able to see it on the screen, but there's a little arrow in here pointing. Now the other way of knowing, since these are actually numbered, the rotation direction is in the number direction as it increases. So on this particular section here, which shows the screw holes, it's numbered 1, 2, 3, 4, and of course, like I said, when there's missing sections, they won't number them. They'll go to the next one that's actually a contact. 9, 10, 11. Well, which direction the numbers go is the direction the switch rotates. Where this one's rotating counterclockwise, and that's what the arrow actually shows. This one here, the numbers are going clockwise, and the switch rotates that way. But the biggest thing that I want you to see on this, more than anything, is the fact that they give quite a bit of information. They're showing the switch as it is, at least one of them. This camera only runs like 30 minutes per time period of operation, making a video. So I'm not sure where it cut off at. I just happened to notice it cut off, so I'll probably repeating some of this. This shows the range switch, but I believe in the manual, which I didn't print out, the rest of it has the other switch as well. There's two switches. One is the, I believe they call it the function switch. It basically is a switch that has the off on it, and then you go to AC ohms, DC minus, DC plus, or AC volts, and DC plus and DC minus, and then ohms, which is right here, the function switch. This is the range switch, and they tell you the ranges. They tell you the range switch is shown in the 0.5 volt DC position. They show you a drawing of the switch as it really looks. They tell you which wafers is which, number 1, number 2, number 3. They tell you front and rear of the individual wafers. They couldn't put it in here, but it would be front and rear for 2 and front and rear for 3. That way when you go back to the switch, these range switches, like here you can see range wafer number 1 front. Well, if we come back, we can see that they're talking about this one right here, and this side of it is this switch. And then range switch number 3 front, range switch number 1 rear, so this is the rear side of this one, and so on throughout the schematic. Now I'm going to bring in probably maybe this one up here. Hopefully you can kind of see it, but the common contact will be the longest arrow, and it will be touching the center part of the drawing here. And then you got the tab here, and as it rotates around, that tab will make contact with some of the others. These are kind of spread out. Down here you can kind of, well, down there where I'm not on the camera, down here you can kind of see this one. Real long arrow. These are shorter arrows around. These are the switched in sections. This one's common. This one always stays in contact. You got a full circle here with a tab, and as that switch rotates around, it will individually make contact with each one of these contacts here, or connections, in each position. Now what that'll give you when you look at it, and you got to kind of sometimes use your imagination, or you can actually kind of draw it in with a pencil on your schematic if you want to, for a certain position if you're looking for. The biggest thing is as long as you know the direction the switch is going and which switch it is. Now when you got a schematic again like this one here, you're going to have to physically look at it on the radio and see where everything connects. You can kind of get, you see where the lines are going, what coils are going to, what other sections of the radio they go to on the schematic, and you'll have to just start tracing that out on the chassis and get an idea how that switch is hooked up and compare it to the schematic, and work out a means for you to understand which direction it rotates, what is being contacted and what isn't. Whereas when you got a better schematic where it does give you a lot of information about the switch, including even the numbering around that switch, then you can see pretty easily direction of rotation as well as what is going to be contacted in each position as it rotates around. In this case, like I said, it rotates in the direction of the numbers as they increase in value. So it's going clockwise. So when it turns, it's going to contact here, and then you turn it again here, and here, and then here, and then here, and so forth, all the way around until we get to 12. Now it'll have it has stops on it, so it stops. It won't completely go all the way around. Again with this one, same way. Here's the common. These are all short, and there's a tab here already hooked to here, and it just, as it rotates around again clockwise, it makes contact one at a time as it moves around. I'm hoping that this is making some sense. Unfortunately, again, like I say, on some schematics you're just going to have to try to look at your radio and your equipment or what you're working on and try to make sense, you know, where things are hooking, you know, take stuff that you can really easily pinpoint out, such in this guy here. You could look at, well, you can find the coils pretty easy, but the way this thing's set up, those are not as easy, but certain connections, well, like to the tuning condenser, that's pretty easy to find. Other connections like these trimmer caps and then the tuning condenser, again, is pretty easy to find. And any connections is going up to the tubes, like from here up to the tube and stuff, again, real easy to find. And you can start tracing out and start making some heads and tails and sense of the switch. And then by turning it yourself, manually turning the switch, you get an idea the direction that it turns. I mean, granted, it turns back and forth, but what I mean is you'll get some sense that from one end to the other end, in case of like a band switch, a multi-band radio, you might say that position 1 is with the broadcast AM band, you know, regular AM broadcast band. And then after that, it goes to the first short wave. That'll be the second position. The third short wave, that'll be a third position, or the second short wave will be the third position. The third will be the fourth position, and so on, however many bands you got. And you can work out and label it out, and if you want to, you can even draw out the switch, the way it looks. If it's a multi-section like this, where you got, you know, 3 wafers going through here, and then also you can label them however you want, front, back, whatever. If it's got connections on both sides, and you can draw out, if you want, the switch itself, how it looks, and again, you know, maybe number the actual connections that are there, and kind of start trying to transfer that to your copy of the schematic, so you get a better idea, you know, when you're rotating it in a particular direction, what is being contacted or not. Again, these are, I'll make sure you can see what I'm pointing at. This has got 2 pieces on it. You can see it kind of slightly a break there. Here, this goes real long. It's a long arrow, and it connects here. This has got a tab on it, which connects to these short ones here as it rotates. You will run into, you know, the drawings will be all the same as far as that type of drawing goes. So I hope this helps you, at least give you some more understanding of how these switches work and what is being contacted and stuff, what makes connections. Again, if you're, you know, if you're having a hard time, you know, like put this in, I don't know, position 3, trying to visualize it there, you can just draw the tab in if you want. It could, you know, each position will be the next contact. So here's a position here, go to the next one is here, that's where it stops, you know, where it clicks in, and then the next click will be here, the next click will be here, so as it rotates around. So you can do that. You know, you might want, if you don't have some listing like this where it tells you the different positions, what they are, you might want to write that out to help you with that. Now, one schematic was requested. Now, it don't have a rotary switch. It has a slide switch. And on this particular radio, he was saying he was getting a little baffled by the switch. On this particular radio, it's a single band radio, but it has automatic, what they call automatic tuning or preset tuning, and it's electrical. It's a Zenith radio, and Zenith, one of the advertisings on it, on this particular model, it's a Zenith 5R312 or 5R316 or 5R317. There's like a few different models there that uses the same chassis. But anyway, they touted this as being the very first electric style automatic tuning, where prior to that it was all mechanically done. In other words, when you push the push button presets, it physically turned the tuning condenser. So it was just all mechanics. Various different ways they could do that, but that's what it was. Now, I don't know if Zenith, it's marketing, it was advertising, and so I don't know if it meant just them or if they meant, this is the first radio that's got this. Which I don't think so, of all the brands. But in any case, it doesn't matter. These are your presets, and this switch, this button here is actually connected. That's this little dotted dash line here, is what moves this switch. Now, this switch is what either turns this radio, so it's manual tuning. In other words, you tune with the knob on the front of the radio, turning the tuning condenser in the dial, or in another position, it clicks in, it clicks that out, and clicks in these coils, individual coils, with whichever one you hit. In other words, you get your presets. Now, it does have a nice little note here. It says manual automatic switch, which is this, shown in automatic position, which it is. We look here, these are the slide contacts. This is the same thing. Now, this, what I got here for a switch is not that switch. I don't have that switch. But the slide contacts are the same thing as the slide, is just these contacts here, here, and here. It's on this, movable piece right here. That's the part that ain't darkened in but drawn out right here. The darkened in parts, those are the stationary contacts. That's the contacts here. Try to keep it in focus. That's right here. That goes to the leads, hooks to the wires, soldered in. These are what are stationary, and those slide contacts slide across to make contact. So this center section moves from here to here or back. Right now it's an automatic, which is easy to see. These top coils here for the switches are the antenna coils. You can tell that because where it goes directly to the antenna. These bottom ones are oscillator coils. These go through and will eventually come up through this coil here. This is all one coil. We have an inductive coupling to the oscillator section of the tube. So if we look at the antenna, with it in this position, we have a signal comes in the antenna. It's going to go connect these coils. Now, when the switch is pushed here, like say this one, it pushes this black piece up against these two. Probably not really black, but this contact moves up. What this does is just connect these ends of the coils to ground so that they're in the circuit now. This end goes and is connected to the other end of the coil and comes down and makes contact through here, through the switch, through the slide, and back up and goes up. Let me back this up a little bit because focus. Okay, antenna down, ground section here. Antenna goes through the contact, the slide, back up, and up to the tube, the grid. which is the way it should be hooked up. You always run your antenna into your control grid of your converter tube. Now, the oscillator, on the other hand, goes through here, and it's going to go through this coil, and we have a temperature compensating capacitor here to ground. It runs down, feeds through here, feeds up, and feeds up into this coil to ground, and then on up to the grid. This coil is what this is doing, is making sure that this oscillator coil is as isolated as possible from anything else. This is giving me inductive coupling. We have a tickler here. In fact, they're using actually two different types of oscillator, or designs of oscillator. When we're using the push buttons, we have this tickler coil that's engaged. That's fed off of this next grid, which is acting like a plate. It's hooked to B+, feeds over this way to the power supply. The grid here is going down and feeding through this coil here, and then back to here to our oscillator coil to ground. We have our, so the oscillator coil will be connected into the grid, and then we'll have a feedback to keep the oscillator going, the kickback through the tickler here. Now, I think his biggest problem is trying to understand when that's flipped up. I went ahead of time and just, since I wouldn't waste a lot of time, drew the switch. So when it's actually pushed up in manual here, what it would look like. A crude drawing, but here it is. These two bottom ones is these two here. Now we just moved the switch into its next position. You can see the two slides are right here and here. They're moved up. The two narrow parts will come up and make contact here. The rest will be making contact with the rest of three. When that's in that position, then what we have is the antenna will feed through this antenna coil transformer to the antenna coil. This is our tuning condenser and trimmer cap. Goes ground on this side. This comes down. One side hooks to here, and this side hooks here. This is all connected to our grid, as seen from right here. So we have these two here are connected together right here. That completes our tank circuit, and then they're connected to the grid, which feeds up to the tube, to the grid of the tube. On the other side, we have this one, this one, this one in contact. Well, these two here make up one end of the tank circuit. The other end goes to ground of the oscillator coil. This is a tuning condenser and its trimmer. And the other end here, which is connected, will go up into the grid. Now this is out of the circuit at this point, because this came down and hooked here. It's out of the circuit, so this is not being used at all. They did this again so they could isolate these coils, so that when you're running manual, there's no potential possibility of these somehow influencing the oscillator coils. So in this case, what they're doing is using a cathode feedback. As the grid fluctuates, the cathode current will fluctuate, and that will give a feedback through the ground back to the tank circuit and keep it going. But the switch just moves one position. And again, there's the new position for manual, and there's the automatic. So again, I hope this helps out, this information. I hope it helps you. If you have further questions, you can go ahead and leave them in the comments. And you know, if you like the video, give it a thumbs up. Please comment, even if I don't get around to answering them too often. I do read them. I do enjoy them. A lot of you guys have a lot of encouraging words. Other people with questions and stuff. I will do videos on them, but it also gives me ideas for future videos. If you like what you see, you have not subscribed, please subscribe, and share the video on Google Plus or whatever else you want to share it on. So again, I hope everybody kind of got an idea, and I didn't confuse you more than help. And about these switches and stuff, I know they can be somewhat confusing, especially when you get a lot of different contacts and stuff. So I hope this helps at least a little bit. And but I think that's about it. I guess I'll say bye now and see everyone on the next video. Y'all have a good day, and I'll see you on the next video. Thanks for watching.